3D printing can be a hobby all by itself, and there definitely is an element of that for me, but the main thing that's amazing about it is that I just love how much more accessible it makes making anything. I want a purely decorative chicken, download it, boom. I want a functional part to hold my phone, pop into FreeCAD, design it, boom. Benchies on benchies on benchies to test things, boom, boom. I think you get the point. Everything is fast, the limitations and strengths are interesting to learn and design around, and this video is supposed to bring you along on my journey through getting into 3D printing, including the hardware, the software, learning CAD, and everything in between, so far. Let's start with the choice of printer and my background knowledge. I have watched a few 3D printer reviews, learned how they work, and had extremely basic interactions with Onshape and Fusion 360 before, just not for my own 3D printer. And even by that, I mean I've literally designed 2 tiny basic rectangular holders, nothing real. So because of those things, I'm not literally clueless, but I'm not knowledgeable either. That said, here was my approach when picking the hardware. With a sub £200 budget, the best options seem to be 1. Scour eBay auctions for something old, 2. A Neptune 4 Pro on sale, or 3. A Bamboo A1 Mini on sale. On eBay, you might find something amazing for a great price, and that's the benefit of buying used. But innovation really does seem to still be happening quite quickly in the 3D printing world, and ending up with an old but once flagship machine is not as nice as it would be with other pieces of tech. Brand new budget printers actually do offer legit good value, unlike many phones, cameras, and other things that I'd normally suggest going used for. Because of that, I narrowed things down to being between a Neptune 4 Pro or A1 Mini on sale. Which do you pick between those? Well, on the side of the Neptune, there's a bigger build volume, more open source software, even if it's old Vox of it, and generally nicer seeming, if less pretty, hardware. And given the non-Pro was literally just like £8 cheaper when on sale, the Pro is the clear choice from Elegoo, regardless of the changes on the non-Pro. On the side of the A1 Mini though, you've got a smaller, prettier machine with seamless, fancy software, including print failure detection and other things that'll realistically mean higher reliability, with the option of a first-party AMS, even if the budget doesn't yet permit. There's value on both sides, but, as tends to consistently drive my purchasing decisions, hardware is immutable and software is not. 3D printers are mostly a known quantity, and I really doubted that Bamboo's special software source would actually matter for me, since I'm perfectly happy to do some calibration and setup manually if it ends up with a more functional machine. And the reliance on open source makes me hope that if I ever do want to do any more significant modifications, be that hardware or software, somebody else or myself is more likely to be able to make that possible. You might be thinking, why go with any of those? You'll get more detailed prints with a resin printer instead, and they can be gotten for around the same price. And you'd be completely right. But FDM is still the simpler and cheaper option, with seemingly better mechanical properties for functional parts anyway, and given this is going in a bedroom where I sleep and the window isn't open 24/7, the fumes are a real concern. Resin isn't the worst thing you'll ever have the misfortune of breathing in, but you definitely don't want to breathe it in, probably more so than the air quality concerns from an FDM printer printing PLA in the background, though beware of other things like ABS or ASA, which are pretty both smelly and not good for you. Trying to say this without sounding like every YouTube review video, here is the Neptune 4 Pro. Given my technically existent but pretty out-of-date printing knowledge, seeing a machine at this price bracket claim to print at 500mm per second, have a multi-section heated bed, a run-out sensor, some beefy part cooling fans, and just generally a bunch of quality of life things, as well as the levels of print quality I was seeing online, my mind was a little bit blown and more than a little bit skeptical. How did things pan out once actually using it? Well, actually, but definitely with room for improvement, which can be realized with one reasonably priced or free mod. From the box, assembly took around 20 or so minutes. The touchscreen UI was fairly self-explanatory. I really should have had this on, shouldn't I? The touchscreen UI was fairly self-explanatory. When it loads, you'll see it. And my first few attempted benchies from the included USB stick failed halfway through because of poor bed adhesion. After properly leveling the bed and setting Z offset and stuff like that, prints were quick and really good looking to my untrained eye. Moving over to the web interface, I'm going to turn this off because the fans are actually, I realise now why I had it off, the fans are relatively loud to be this close to it. Moving over to the web interface, I thought, wow, that looks good too. I could plug a camera in, which is really nice, this is an old PlayStation Eye camera, start prints and generally control things. But it was also the place where the flaws in Elegoo's mostly open but slightly custom way of doing things started to show. It's nice that all of the standard base stuff is FOSS software, But updating it can break everything, since it's combined with an old Linux kernel and some custom Elegoo software for the screen that's not open. And it's all super out of date compared to upstream. Also, running calibrations from the web UI, Fluid, seemed to save things to a different place or under a different name than from the touchscreen, so I was never really sure where I should be setting stuff from. Plus, the built-in buttons to turn on or off the LEDs from the web UI just didn't work. Only the toggles ones did, but not absolute on or off. As revealed by the cool software mod we'll be doing later, it seems like there were revisions to how lights are controlled, and I was shipped a printer with newer hardware, but software configured for the older way. That's fine, knowing I could just use toggles as a workaround, but shipping with literally non-functional buttons in a menu without any messing by me yet is a bit awkward. While we're all aboard the meh train, a 500mm per second max print velocity is literally possible, but really 300 is the max that I'd use, and 250 is what I use for nice quality, and the max acceleration of the printer being 5000mm per second squared by default means you're not going to be getting anywhere near 500mm per second of velocity unless you've got a huge print, since it's going to have to be changing directions a lot. The huge part cooling fans definitely can get louder than I'd like, which might be considered a negative, since the defaults definitely push them harder than you really have to. But in my profiles, I've just got them set to 30 or 40%, so I can't really complain about having tons of headroom in case I want to push the potential crazy speeds that Elegoo says this should be able to do. Also, we will be talking about slicers and other software later, but Elegoo suggests you use Elegoo Cura. Don't. It's old, and upstream normal Cura and Orca Slicer have had Neptune 4 profiles that work perfectly for quite a while now, so I won't be looking at their own branded versions of open source slicers because there's just no point. Very sorry, I forgot to mention this, and it's a huge bonus, so it's really important that, and despite me just glossing over it, this printer came with tons of extra stuff, and that was excellent for someone who's brand new to 3D printing like me. It came with screwdriver, it came with all of the necessary tools to put it together. It came with 2 extra nozzles, a USB flash drive with a bunch of built-in models on it, a micro SD card reader with a small micro SD card in it, a replacement PTFE tube, some included PLA+, which I haven't used, but it's not a whole roll, but it's still something to get you going, a glue stick, some grease, cotton, like a Q-tip to stick up it somewhere, and even some cable ties, which I didn't end up needing, but that is really nice, especially for a printer that is not, some £1,000 super crazy premium thing. The parts cost of all of this probably isn't that significant, but the extra level of care and confidence that all I need is everything that comes in the box and then I can get to using it is great, and Elegoo deserves lots of praise for that. For the software actually running on the printer itself, there are 2 types of changes that I would strongly and maybe recommend respectively. The first is that I'm confident in saying you really should lock things down. SSH is open, API access and the web interface are open, camera feed, everything wide open, with the default credentials you can easily find online being used for SSH and no login for everything else. If I was a bad actor on your network, not only could I control your printer and see through any connected cameras, but I could put any software at all I wanted on this, effectively, full Linux computer. I mean, I do get it, the way you're supposed to interact with it is through the touchscreen, but there really should be at least some advice in the manual to say, if you're gonna put this on the network, change everything and here's how. If you're wondering what exactly I did, I uninstalled a bunch of packages, including XFCE, ZSH, and the WireGuard VPN client. I also changed the ports for everything, added a new custom user account for the web UI and general network control API, added HTTP basic auth for the webcam stream, and made it so SSH is only accessible through a new, unique public key, all of which makes it so you can't access the printer over the network in any way using the default or no login. With all of that done, it was nice that things were more secure now, but I still couldn't update any 3D printing related things because, again, that breaks everything. Though, big props for at least having unattended upgrades in Debian enabled. That means that even if the 3D printing stuff won't update itself, the Linux install itself will basically automatically patch itself every day. Plus, although extra security is obviously something I want, I was never going to leave the printer on all the time anyway, since the idle power draw is just over 10 watts, which is probably more than is reasonable for something I don't need on all the time. So realistically, I wasn't at too much risk of it randomly being hacked, especially since it's not touching the internet, just your local intranet. So I wasn't too concerned about the lack of auth, but I feel that it's not great that there aren't any kind of instructions to change things from the defaults, and why have security holes when you can not have security holes? But even with all of that done, the old included software is still kind of a shame, and something you wouldn't have to live with if you were building your own printer. Luckily, as I've referred to a few times, there's a software project that fixes that called Open Neptune. Open Neptune basically takes regular Debian, or Ambien, installs the necessary software to make it run on the special processor in this printer, and installs fully open source and upstream versions of Fluid and Clipper. So that's a web UI and the software that actually tells the printer how to move based on the G-code it's been supplied with. And they even build custom software to let you still use the stock touchscreen if you want to, though that part's in beta and I still use the web UI. But that's all bundled together into one software package that completely replaces what came on the printer by default. Basically, it takes it from very clearly being an Elegoo 3D printer to just a 3D printer that Elegoo happens to have made, but that is fully open, and it can be treated like any other open source machine. On the Open Neptune GitHub, there are comprehensive guides and explanations for different versions of the Neptune 4. So I have the Pro, newer, hidden SD card, higher amperage motors, newer LED control version, and a Discord server, which I relied on heavily for support. In the end, I decided on not using any of the custom Open Neptune slicer profiles or some of their changes to printer.config, since they limit the max velocity and acceleration lower than I'd like to, but I do use their firmware, and I do go fully upstream with the rest of the software. Plus, although the advised installation method involves buying a 32 gig replacement flash module, and I did go for it since upgrading from a stock 8 gigs just felt like a good idea because that's not much storage, you can even do it for free by replacing the software on the stock eMMC module through the serial/USB-C awkward mix port on the front. Though do be advised that it's not my or Open Neptune's fault if any of this goes wrong, no matter what method you use. However, I will say that I've had a great time with it, and I was already completely happy with the hardware of this printer, and reasonably happy with the default software, but that also moves up to extremely happy with the software once it's on Open Neptune. It just makes me that bit more confident that I'll keep getting new features and bug fixes and general software support, while being able to tinker with more things myself, not worrying about what awkward non-standard things did Elegoo do on the stock installation, and how might I break them. But alright, I've got a working printer now. How do I get it to make stuff? We'll get to sourcing models, be that from the web or designing them yourself, shortly, but first we need to look at calibration and slicing. Calibration's fairly self-explanatory. What do I do to take this printer from its stock configuration to something that works best for me? But slicing might be new to you if you've not looked much into 3D printing before. We'll start with calibration though, since even an amazing model will be ruined by an uncalibrated printer. The most obvious thing, and the first that I messed up, was leveling the bed. 3D printers tend to have some way to measure the position of the bed relative to the nozzle, and that lets it correct for the unevenness of the bed in software. But there's also the ability to just actually level the bed in hardware, which should generally be preferred. What's really nice, beyond just getting numerical readings, is that Fluid can show you a 3D representation of your print surface, a bed mesh. And a big advantage of Open Neptune, and you can do it for any other printer manually too, is that it makes it as dead simple as adjust this spring this many turns, that one this many turns, and so on, and it'll basically give you a perfect bed immediately. Despite bed leveling being the most obvious, there are tons of other calibrations that you can do, like PID tuning, which is completely automatic and helps your printer understand how it heats up relative to how it was asked to heat up, so it doesn't under or overshoot the temperatures it's meant to be reaching, and maybe a bit more manual and subjective, temperature towers. These help you pick the best temperature for your filament by showing, how does bridging work? You can see the little droopy bits. How is layer adhesion? So you might be able to tell from close-ups. I've actually tried pulling this apart so the top things are kind of curved. And then you can just pick from the numbers on the side which seems like the best and then set that in your slicer. Before doing the temperature tower, I used to print at the default, I think 210 or 220 degrees at the nozzle and 60 degrees on the bed for my PLA. And I still do with my weird colored filaments. We'll get to that later. But for my grey PLA, I realized that I could actually be printing as low as 180, and it was perfectly fine. but the manufacturer website suggests I go for at least 190, so I picked 190. As I said before, higher temperatures lead to better layer adhesion and the ability to print faster because it's more liquidy, but worse bridging and potentially more fan speed necessary to counteract some of the more gloopiness of higher temperatures. Speaking of things that can make unpleasant sounds though, wrongly tightened belts. Too tight and the belt and motors will wear out faster and maybe skip. Too loose and you will also get skips. My Linus Tech tip for finding the right tension, since everyone seems to have their own way, is to loosen them a lot, move your axis as far as possible to one side, slowly, since an unpowered motor is a generator and you don't want to be sending current back to the motherboard, and then press on the other side and tighten it until it's just about not floppy there anymore. Then you can print something. If it skips, tighten it more, but hopefully it doesn't, and then I give it just another half a turn just in case. That way, it shouldn't be too loose, but it's as loose as possible, which I hope will help longevity, but again, I'm new to this. The final calibration I'd suggest doing, even if it wasn't very impactful for me, is calibrating your E-steps. The actual hardware that moves the parts on your 3D printer are called stepper motors, and like the name suggests, they move in discrete increments, steps. And so it needs to know how many of those steps get them to move some real-world distance. If you get that wrong, your printer might try to move 10 millimeters, but move 11 or 8. Look up a tutorial for the exact details since you'll have to enter some G-code manually, but it basically goes, mark your filament, extrude a known distance, measure how much that mark moved, and then put that into a formula to figure out how many E-steps you were off by and what to adjust it to. Mine was already spot on, thanks to Open Neptune, but it's such a fundamental thing to get right that you really should check it just in case. Also, besides the extruder, if you want to make sure your X and Y axes are right, you can print a little calibration cube, and then you can measure these with some calipers and hope that it's exactly right. For me, this is exactly 20 by 20. I also printed a tiny one that's exactly 10 by 10. Once you think all of the fundamentals are decent, you can test things with everyone's favorite print, at least until last month, but it doesn't seem like everyone's certain of the details and everything's kind of been resolved now, so I'll stay out of it since it's a legitimately useful model, regardless of anything else. Benchy. A Benchy is like a bundle of a bunch of different tests packaged in something that wouldn't be too bad to end up with a flock of if you end up doing a million different calibration steps like I did. Poor cooling will lead to a weirdly deformed bow and smudgy chimney. The wrong Z offset will lead to barely legible bottom text. There are tons of different things and official size marking, so you can also use this instead of a calibration cube if you'd like to. And if a Benchy's just too fun for you, there are some more clinical calibration models that will give you more details, even if they're a bit less fun, but I'll let you discover those. But if you've got no models to print, what's the point of a working printer? As far as acquiring models goes, I've been really surprised when looking online, since it seems like so many people who have a 3D printer don't have any CAD skills. And I'm not saying you need to be the shroud of Fusion 360, but I really thought that most people buying a 3D printer would be doing so because they have some kind of custom part in mind that they want to create, and they want to be able to manufacture it and any future similar things. But no, it seems like what most people want to do is either make functional parts that aren't unique enough that there isn't already a downloadable version, which is fair enough, or people really do just want little knickknacks. In fairness, a reason's a reason, and if you want little figures and vases and everything, go for it. But I beg of you, if you own a 3D printer and you don't know how to make parts yourself, you are missing out on so much. Every mechanical problem in your home goes from, oh, that's annoying, to, I bet I can fix that, if you can just get by in parametric CAD software, and it's wonderful. But for downloading models, if you don't want to design stuff, if your problem's shared by other people, you'll probably find something on either Printables or Thingiverse. But wherever you're downloading things from, make sure it's a 3MF, step, or STL file, not G-code, since the former three contain a model that can be adapted to your printer, but the G-code is just G-code made for someone's specific printer to tell that printer how to move. So you probably don't want to rely on someone else's G-code. If instead you feel like making your own model though, you've got a few options, but probably 6 real ones for different reasons. Onshape, Fusion 360, FreeCAD, OpenSCAD, Blender, and Tinkercad. Onshape and Fusion 360 are full-on parametric CAD software, made to help you make functional parts with strict size requirements. And they're probably also just the most proper in that list, but with proper proprietary paid price tags. There are free tiers, but with restrictions on what you can do and the models you make, including the fact that all of the models you make in Onshape have to be public, and all of the models you make in Fusion have to be, they cannot be used commercially. FreeCAD addresses exactly that, and it's my software of choice, but it's definitely not perfect. There is a reason people do pay for that other software if they need the utmost in quality, but if you first heard about FreeCAD a few years ago, it has been significantly debugified and made more intuitive since then. And since designing parts isn't my job, and I'm not doing it 24/7, and it's similar enough and workable enough when compared to other parametric CAD software I've used, it definitely gets the thumbs up from me. And I strongly encourage you to at least try it rather than going straight to the defaults, since more people using this open software will, first of all, just lead to you paying less money and having more freedom. And secondly, FreeCAD just gets a bigger community and it can just keep on getting better. It's a snowball, so consider trying FreeCAD. As for the other three, they're all weird in their own ways. OpenSCAD is something I really need to get more familiar with before I can say anything definitive about it, since it sounds like it could be cool since you make everything straight in code, but I've not taken the time to get good at it yet, so I can't properly evaluate it other than saying I like the idea, but it's very different to everything else. However, there's actually an OpenSCAD tab in FreeCAD, which I didn't realize until writing this video, so go open source software. Blender is not really CAD software, even if there are add-ons to help you, and I wouldn't use it to make any functional parts. But if you're just designing something visual, or if you cannot get to grips with parametric software, it's easy to learn, and again, useful to know for any visual-focused 3D modeling work, 3D printed or not. And finally, I've heard good things about Tinkercad for beginners, since it's got some of the increased control of parametric CAD software, but not too much though, and it's kind of a mix of preset parts and a friendlier interface and a bit of parametric-ness. But I wouldn't know, since I don't want to have to make an account, it's only in the browser, and it doesn't seem like what I want anyway. All of that covered now. Without turning this video into a FreeCAD or general parametric CAD software tutorial, the general vibe is that you'll take some real-world measurements. Digital calipers can be very cheap, like low single-digit pounds cheap, and still very accurate, so get some. And you'll make a sketch of the shape you want, constraining some general 2D shapes from being free-floating, more artsy rendition of what you want into definitive actual measurements for exactly what you want. And you'll know that you've done enough of that when your part is fully constrained, and that means dragging things around with the mouse won't work because some form of measurement is keeping things locked in. And then at that point you can extrude that 2D sketch into 3D, make another sketch, use that to put holes in the first one, so on and so on, until you've got a part you're happy with. There's way more to it in reality, but I think that's a fair way of describing how it generally works, and if you actually try it, you'll see what I mean. It's basically that simple. It does take some time to get used to, and you'll have a million, wire not closed errors and a bunch of little awkward things. You'll have to decide whether you want a big sketch that contains everything or split things into a bunch of little sketches. It's a little bit awkward, but once you've made a few parts with it, I think you'll find that you will start reaching for it to solve problems rather than being too intimidated by it. Just get over the first little hump. But you might be thinking, even though my printer works fine, and even if I've got a model, I just don't know how to make my printer print it. I can just send a Word document, PDF, or TXT file to my 2D printer, and it prints. But a 3D printer apparently needs something called G-code? Does that have anything to do with Half-Life? No. In fact, G-code isn't even specific to 3D printing. It's used by all sorts of computer-controlled moving things. And that's because all G-code itself is instructions for how to move all of your different movie bits to produce the desired outcome, be that cutting a block of metal down on another machine, or building a block of plastic up on a 3D printer. As I said before, when saying you shouldn't download G-code, that's exactly why. You probably want to be generating the G-code yourself, since yes, you've got the same model, and yes, you want the same outcome, but G-code takes into account the capabilities of your materials and your machine. So someone else's materials and someone else's machine is going to be different. So even if you've got the same printer, you probably don't want to be using someone else's G-code because they might print at a different speed preset or with a different material. And if you've not got the same printer, you almost definitely don't want to be using someone else's G-code. Don't worry though, because even though there's some tinkering to be done, it's not a manual process. And the software that actually generates it is called a slicer, because it slices your model into the individual layers that your printer needs to be able to print and tells it how exactly to do that. The two slicers that you should probably care about when getting into this are Cura and Orca. Why not Prusa, if you've heard of that? Well, because Bamboo Slicer is based on Prusa. And why not Bamboo? Because Orca is based on Bamboo. So going with Orca, you get the whole chain of benefits by just going with that. Orca is probably better than Cura in many ways. But I tend to stick with it because it just has better vibes, like the menu fits much better in my head, as well as the legitimate benefit of it having a much better Flatpak because it actually supports desktop portals, so you don't need to give it file permissions, and Orca doesn't have that, so it's kind of awkward, as well as it printing slightly faster and nicer than Orca does, even if I try to match all of the settings, and I've got no idea why that is. Regardless of the slicer you end up going with, the general situation is as simple as a 3D model in and G-code out. You are able to configure temperatures, speed, acceleration, infill types and amount, which determine how much plastic you want to go in the otherwise solid bits of your model, so you can weigh how much plastic you want to use against how much strength you need. But the basics for all of these should be available as a preset for your printer when you first launch the program. One area that I tried to avoid learning about for as long as possible is supports, because as the name suggests, the idea is to better support things that would otherwise be printed over air and therefore not work. But ideally, you just wouldn't want to be using them, both from a this harms the surface of my model perspective and this uses extra plastic which costs me money and hurts the environment perspective. So I avoided needing them for any models I designed myself, but I did need them for a few models that I downloaded online, for which I tried both organic and normal supports. And yes, that is a pile of rubble from a single print. It's not actually that bad, that's about 30 grams of plastic, but that's still money. But at least it's a very satisfying process to take off. I'm actually kind of surprised it's not become like a short form video trend Family Guy Subway Surfers thing. It sounds really nice and feels really nice, but all of the little bits of plastic you snap off are money basically being burned. For that part that you're seeing on screen, I actually ended up using Orca for it, despite saying earlier that I always use Cura, because supports are just much better in Orca, which I presume comes from Prusa Slicer. In Cura, you get to tell it where not to put supports if supports are enabled, and it will try to generate supports around the bits that you don't want it in. That can be important for parts where you couldn't really scoop the supports out of a hole that they might otherwise generate in, or if you know that your printer can print this fine so you just don't need supports in certain places. But it's pretty awkward if there are tons of supports and you've got a very organic shaped model to put a bunch of cubes in the places that you don't need them. In Orca, you just get to tell it where you want the supports. You can manually select faces, you can paint them on. It's just a much, much nicer process. So even though it took much longer to print than if I would have used Cura, I ended up with a much nicer part because of it. One thing that I definitely suggest you add, especially if you like optimizing your parts as much as possible like I do, is your filament details. Like, I know you've already got the temperature and stuff, and maybe you even changed it for the generic profile so it works best with your printer, but I mean adding the weight, the manufacturer, the color, the price per weight, rather than leaving everything besides the temperatures as they were by default. It's not absolutely necessary, but when you end up switching between filaments, it's really nice that you get reminded which you picked based on the color of the things in the slicer preview, and given the slicer can figure out the weight of a model when you slice it, putting in the cost per weight lets you realize, oh, maybe this model costs a whole pound to print each time, I should be more careful with the optimizations I make. This other one costs 10p, so it's fine for me to rapidly prototype it and not care too much if things go wrong. Combining that with a plugin that lets me get thumbnails on the printer, which can include those extra details, and it just helps make the whole slicing experience much more useful and a bit more understandable. My final little tip with slicers is to make sure you print multiple objects one at a time if possible. It used to be that printing multiple objects on one bed, they would have to be printed layer by layer together, but modern slicers know how big the print head is, so you can tell them to just print two objects one by one far away from each other so they don't hit each other, which can not only save time, but also increase quality. I admit, the picture you're looking at right now was a print with one wall, so the quality was never going to be great, but just look at how bad these are. These are by far the worst looking things I've ever printed, and they were done next to each other, printed on the bed together. Now, let's look at what they looked like one at a time. Yes, it's not the best afterwards, it was still one wall, but you would expect things to not be great from one wall. The one at a time print was way, way better, and I'm not sure exactly why that was, but I am going to tell you, if you have multiple things to print, try and do it one at a time. Extra note, I didn't actually write these, but it can also save you time, since the printer has to travel less in between prints, so just do it. And second to last, actually printing and using these materials and that kind of thing. Whether you've got to load a file onto a USB drive and start the job from the onboard screen, or if you're sending all of the prints over the network through a web UI, all you need to do now is make sure your print bed is clear, material is loaded, and print. Some people choose to put glue on their print beds for better adhesion, and maybe this is more relevant if you're not using a textured bed like me, or if you're doing huge parts, but I tend to avoid it since adhesion is already excellent for me without it, and I don't want to add mess and another consumable. At least with grey PLA. With this silk PLA though, the purple and green stuff, things were a bit different. The half blue, half purple roll was very finicky, even at much increased temperatures over regular grey PLA. It basically always peeled up with larger prints, though small ones were fine at basically any temperatures I used. And the silk mint green colour was actually fine, but still needing those higher temperatures for good adhesion. Though, normally I don't print things that take up the whole bed, so I default to, I think 210 degrees at the nozzle and 60 or 65 on the bed for it. Basically, I know now to avoid silk materials in the future, since I just looked at these and saw that they were fun colours, and I wanted one boring colour and two fun colours. But silk colours actually have different properties that lead to worse layer adhesion and worse bed adhesion, therefore needing higher temperatures, and I didn't know that before, and you might not if you're very new to this, so please take into account the different properties of different materials if you're getting into this. I'm not going to get into the different types of materials here, mainly because I haven't used them, so I don't have much to add, other than the general stuff, which is to say, this is all PLA, even if it's silk PLA and not silk PLA, which is the most common, the easiest to work with, and it's very cheap. But there's also PETG, which needs a bit higher temperatures than PLA, but is much stronger and not much more expensive. There's TPU, which is flexible, and you'll need to print slower with, but if you need something flexible, you need TPU. And there's ABS and ASA, which I don't plan on ever using because they are smelly and more toxic and more awkward and more prone to peeling off the bed and that kind of thing. But I think that they are supposed to be more similar to the kind of plastics you normally find on injection molded things. So if you want those kinds of properties, maybe you'll want ABS or ASA. But getting back to the awkward silk PLA materials here, I'm sure I could lower the temperature and keep fine adhesion if I was willing to glue the bed, but I'm not, so. Speaking of the bed though, when intentionally taking parts off, I only recently learned of a very obvious trick. Which is faster, to cool down specifically. Leaving things on the print bed, which is still hot, and letting it cool down while the heaters themselves are still cooling down, or just taking off the magnetic print bed and fanning it, because you can do that. Obviously the second, but I just never thought about the second until I saw someone in real life doing it and thought, that's genius. If you're wondering what I've actually gotten to take off that bed right now, here's a list of some of the important stuff, excluding calibration things and anything else I forgot. I will start with this filament holder. I think I can take this off fine? Yeah. So this printer comes with a filament holder that screws into the top of it by default, but the plastic thing that actually holds the filament, there's only one of them. So you can screw it into the left or the right, but not both. However, someone put onto printables just the same model that, I think you can see I can screw it on and off. I'm not going to unscrew it because it was kind of awkward to screw in. I printed this at 0.3 millimeters layer height, and although I was originally a little bit worried about the kind of levering force on it, it has been perfectly fine, and I imagine it's going to stay perfectly fine. So it's nice to be able to have two filaments, though I can't print from both at once. It's just nice to have them up there. The second was a little chicken that I scaled down a lot. So maybe it's a bit more messy than it would be if it was scaled up, but it went fine, and there's not much else to say other than this was the only real knick-knack that I printed before realizing it's not really for me. Next, there are a bunch of fun mounts for the iPhone 11 that I live streamed replacing the screen on to use it as a camera and software development phone. That's what you're looking at me through right now. And this was actually really cool because I went through a bunch of different revisions, some of which are not visible here, some of which are, the basics, even once I had the general shape down, I first just started putting holes in it to use less plastic but didn't constrain them, and then I got to properly arraying a uniform like set of hexagons to cut things out of so it looked nicer. I printed just a rectangle that was meant to be the exact dimensions of the phone to see if that would grip it and what kind of tolerances there are. And it was particularly cool just going through a bunch of like product development cycles, essentially, even if it's free and open and you can find it on my printables account, and if enough of you download it, I'll get a free roll of filament. Like, originally, I was imagining that the general shape of this would just be a circle, and then I would grab two sides of the one corner that the camera bump is along, and that would be fine. And honestly, this was fine, just relying on gravity, but if I turn the phone upside down or anything like that, it would fall out. So I was like, okay, well, I will add a bunch more grabby bits. I will add one to all corners, and everything will be fine. And it was, but after deciding I still wasn't perfectly happy with all of the hooks. I think this is the one with the perfectly happy hooks. This is the one with much weaker hooks. But after deciding I wasn't happy with the hooks and redesigning them, I then realized it was actually gripping the phone perfectly fine without the extra arm bit. And then I got to go back from, ooh, I'd really rather this be a circle, to, oh, but I need more grip, to, oh, now I've actually got enough grip that I can go back to it being a circle. It just taught me a lot about designing things. It got me a lot more familiar with FreeCAD. It was probably the most significant thing that I've printed. It also taught me that non-bridged, non-anything overhangs are just about possible. Even if this only 2mm long one is pretty ugly on the bottom, it does work. I also got an A1 owner to print it on their printer. That's not an A1 Mini, a regular A1, so a much more expensive printer than this, though we didn't coordinate print profiles or match materials or anything, so this comparison isn't super scientific. Next, as a work in progress, I've got a monitor-mounted USB hub being made, which right now is just a rectangle that can hold PCBs, so hold the monitor mount, we'll get to that later. And a few times I've tried to design a little puck to charge my mouse with using the power play pad, so I'd have magnets and power those and things like that, but I've not yet come up with a good way to attach the two halves. Both of these things have in common that I need to get good at making snap fits. This is my first test of doing a snap fit, that's how the front attaches. It's working pretty well, but they're not small enough to go inside a mouse yet, so we'll see how that goes. Back to a bigger and more complicated print, and definitely the most awkward. This is a Quest facial interface. You might be thinking, what? You've already got one. And I do, thanks AMVR. But the main focus of that is the cushion itself, not the plastic. So what if you bought a Quest 2 at some point, but now have a 3S or 3? Well, boom. It does look pretty messy, but subsequent prints that I tried in different orientations and with different kind of supports went much better. And it's actually just a really cool concept. Like, I have this other one where I actually bothered to paint the insides black so it wouldn't, you wouldn't be able to see through the slightly translucent green filament, and put the actual Velcro things on it necessary to connect to the facial interface. It's definitely not as strong as the original ones, and these clips printed very poorly the first few times. They snapped off until I got layer adhesion just right. It's a little bit more finicky than the proper one, but it can work fine. There are still some unaddressed things, both in this video and in my mind when it comes to 3D printing. For one, environmentally, and just from a general perspective of not wanting waste, seeing all of these piles of full-on parts that never got used because they were prototypes, brims, supports, and just general bits of wasted plastic, not even considering all of the visual designs that other people print that basically serve no purpose. Even this vase, I probably didn't need a vase. I've left this flower in it for too long. But I thought, ooh, a little vase would be cool. 3D printing definitely encourages you to waste a lot of plastic. That said, if you take out the prototypes, since it's not like prototypes are inherent to 3D printing, as you get better designing, you'll need less of them, and basically everything requires them. You will always waste some resources making prototypes, and if you don't use supports, which is reasonable for most functional parts I've come across, it's probably also true that the strip of plastic at the front and a brim is actually much less plastic and represents less CO2 emissions than packaging and shipping something of a similar size to what you would 3D print. Although it doesn't discount any negative things, the level of empowerment that 3D print brings in letting more people design useful things is huge, and I think does offset any of the negatives waste-wise, especially when you consider, this is the same argument as any waste things. Big companies will tell individuals, use paper straws, make sure you minimize everything you're doing. Meanwhile, companies will spill oil into the ocean and waste plastic at monumental scales. So I wouldn't feel too bad about having a 3D printer. Sorry, my microphone batteries died, so I really hope we got through the last little bit without you having to deal with the camera microphone. So I'll pick up where I left off from. So that was, I wouldn't feel too bad about having a 3D printer, but I would definitely feel bad forgetting to tell you all about my very, very patient and much appreciated supporters. That's Innerbox, Fluffy Meowl, Russell Willis, PT1997, Novus 4K, and Pytech. Obviously, as I always say, I really appreciate it. And again, feel free to let me know if you ever want supporter perks, because I would be happy to provide them. But I really appreciate you all, and anyone who subscribes, I also really appreciate it. Hopefully you've enjoyed. Hopefully this wasn't too scattered, since it was just a combination of a million notes over the course of 2 months. But hopefully it either helped you get into 3D printing if you're actually considering it, or just served as some entertainment if you're not. Hopefully you've enjoyed, and I'll see you in a week or two. Bye.